All right. Okay, so in this video, we're going to open a CAD file that a customer sent and generate the code to cut out the shape of the core, drill the binding holes, and countersink the bottom side of the binding holes for the inserts. And I'll show you how to do that right now. Here in this case, we do File, Open. Customer sent an IGES export from AutoCAD. It tends to be the most compatible format from most CAD packages into this old version of Bobcad. So I'm choosing that instead of some of the other options, even though that seems a little unusual. And select that and open it, just using the defaults on the import filter. And you can see here's the shape of the core with the binding holes. They've supplied a side view of the core thickness profile as well as the tip and tail plastic shapes. I assume they just did this all in the same file, but for this particular exercise we do not need these two things. I'm just going to highlight and delete them. And next thing I'm going to do is just check to see if this imported to scale. For the most part, Bobcad tends to import everything as inches, so if he set up his file in millimeters, it's going to come in red as inches and be too big. So the way I do that is I go Dimension, Horizontal, because we're measuring this way, and while it's highlighted I'm going to put the first point right on this tip piece here, and the second point right on this. It just sort of snaps to the points, and click, and then I'm going to use my V key to get the magnify zoom tool and draw a little box here, and you can see right there is where the tiny little, yeah, you can see it came in as 33,000 millimeters long, which is a little too big for this board. So it did very definitely read it as inches. So I'm going to hit Control Z to delete that, Z to zoom into the rest of the drawing. And then what I want to do is divide this by 25.4, 25.4 being millimeters to inches, and that will convert this file and scale it down into metric. That's assuming it was done at 1-to-1 and it appears to have been in their file. So I'm going to go 1 divided by 20, oops, CE divided by 24.5, or sorry, here clear. 1 divided by 25.4, 24.5 would have made the wrong scale, equals 0.03937, blah, 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 blah. I'm going to edit, copy that, and then close the calculator, and go change, oops, I have to select this geometry first. Change, rotate, and I'm going to rotate this file 90 degrees so it's oriented the way I want to cut it on the CNC. And I'm also going to scale it at the same time and go Control V or Edit Paste, right click Edit Paste, does the same thing as Control V. 0.039, I've got that number in here, I'll go OK. And you can see how it rotated 90 degrees and moved way down here all small because it's 25 times smaller. And now we need to move it over here, with this being the left edge of the CNC router table in virtual space and this being the bottom edge of the CNC router. We want to import it sort of in the lower left corner. So I'm going to go Change, Translate. I'm going to change the scale back to 1 because we don't want to scale it again. So 1 here, and I put a 0 there just to make sure it's not doing any weird stuff I don't want it to. Oops, that's 8, 0. And I'm going to hit the drag key here, and then you can see as I'm not holding any mouse buttons down, just I move my mouse around and you can see it sort of has a virtual representation of where it's going to go. I'm going to move it approximately into position, hit the left mouse button, then hit the right mouse button, and then that deselects everything and that is no longer active. I'm going to hit the V key to zoom in on this end and just see where I'm at. Now, in this case, when I highlight the geometry, you can see that I'm approximately 17.94 millimeters from the y-axis on that point. So I'm pretty close, but I want to be approximately 20, so that's 17.94 is roughly 18. So I'm going to hit the Z key to zoom out and change, translate. I'm going to move that 2 millimeters on the y-axis, and I'm going to zoom in here again, and when I select, not even selecting, I'm just highlighting, and sorry, I must have selected this one. So right here, when I highlight it here, the first one is reading 17.784, so I need to go 2.226 to increase, to move it. So change, translate on the y-axis 2.226. That'll move it a tiny bit this direction. I'm going to zoom in here, and this first point should now be around 20, say 20.01, so we're basically 20. And I'm going to check the distance from this point to the y-axis, so I'm going to use my, I'm going to use the V key to zoom in, and again I'm going to highlight here. Oh, actually that doesn't give me a point. I'm going to just quickly put a point by using the point end, and it puts a point there. And then when I highlight near this point, it says I'm 13.17, so I actually want to go 6.83 this direction in order to be 20 from that axis. So I'm going to zoom out, select everything, 0 on Y, and this time I'm going to go X, 6.83 I think I said. Okay. And that should be pretty close to 20.00. That's totally close. So that way, you know, the reason I position it at 2020 is because when I put a core blank down here, I want to basically center this file on the core blank. So I tend to put the core right along the 0 line here and right along the 0 line there. So if I select index the machine so that 0, 0 is at this corner, then this is positioned to cut, you know, centered on the particular core blank I got, assuming that the core blank is approximately 20 millimeters wider on the right side as well. Anyway, so now that that's in position, what I want to do is I want to select all the binding holes to drill the holes. Then I want to countersink the base of those holes for the binding inserts, and then I want to cut this perimeter shape. We're going to do that in 3 separate things, but we're going to do it all on this one file. So first thing I want to do is insert an NC command here. Mach 3 Marco is the one for Mach 3 is the post processor that we use on the CNC multicutter. So I'm going to hit OK, and you can see it opens the cam window here. And then I'm going to hit on this side, click on the left side so that we're active on the left side. I'm going to hit the V key and zoom in, and I'm going to select all the circles, and I want the arrows going this way, so I select on this. If I select here, you can see the arrow goes the wrong way, but if I select on this side, the arrow goes towards the thing. So I'm holding down the control key and I'm selecting all these holes. And what we want to do is put a point in each of the center of these arcs, because the drill command works best with a point instead of these arcs that are there that represent the binding holes. So I'm going to keep selecting. I've got the control key still held down here, and I'm selecting all the binding holes. I think that's all of them. Yep. And I'm going to point, arc, center, and you can see, boom, that one command puts a point in the center of all those inserts. And coincidentally, since we did them all at once, they're all highlighted at the same time. If I hit the Z key and zoom out, you can see there's still the little red dots in all those holes. Now, on the right-hand side, there's a neat little wizard called the Drill and Cycles wizard, which if you select it and select J81 spot drill is what you want to do for these, select that and hit OK. It opens up a dialog box that gives you R value, which is retract, and that means after the whole, like how high off the material is this bit going to be before it starts drilling, and how high is it going to retract back out of the hole after you drill it. Now these core blanks that the customer supplied to me are 9 millimeters thick, so I'm going to have the retract value, I'm going to set it at about 20, so it's actually going to retract a fair ways out of the hole. In fact, I could probably even go, yeah, 20 is fine. And then the plunge feed is the same feed rate that you want, and I typically use 250, which is pretty slow, but it gives you a chance to, you know, it's not moving super fast and gives you a chance to stop things before a whole bunch of holes get drilled really quickly if it's making problems. The hole depth, if you go right down to 0, it's going to drill completely through the material, and you run the risk a little bit of putting little marks on your tabletop if you go all the way through. So what I usually do is I usually set this at about 0.2, so that the hole goes all the way down to 0.2 millimeters above the table, which leaves just a paper thin piece on the bottom side of that hole that's really easy to poke out, but it also keeps the top of your table looking really clean, and it doesn't get marks on it from accidentally drilling or routing through it as easily. And you'll see that I do that on most steps when I'm doing the cores. And the return mode is 99, and I just hit OK. And here you can see it generated this red line that goes from all the holes, and here's the G code to drill all those binding holes. So that step is completely done. So click here on the left side again, because if you start doing any commands here, you start accidentally typing stuff in the G code and you screw it up. So click here before you do the next step. Now the next thing we want to do is, this started down here and went and drilled all these holes, and it's up here, and the very last thing it did is over here. So I'm going to zoom in with the V key and start the countersink operation on this insert. Now, unfortunately, the countersinking operation is a bit of a pain in the ass, and it takes a whole bunch of, each hole you have to do separately. It's not difficult, but it's just a lot of clicking and typing and clicking and typing, and it's real easy to kind of mess up as you go. So it's more of a kind of a pain in the ass thing to do, but it's still cool that there's a little wizard to do it. It's not as hard as doing manual core. So for this command, what we want to do is a machine profile command. You want to select the circle, and the same way we did the last one, we kind of want to select it in the middle and get the arrow so that it's going to the right, and so that the router is moving counterclockwise, the way I mentioned earlier in the video. So I'm going to click on that, and then I'm going to hit the F3 key. Oh, click on the, sorry, here, I'll do that again. Here, I screwed that up. Okay, so go machine profile, click on the geometry so you get the arrow going the direction you want. Click again, that's the step I forgot earlier, and then hit the F3 key. Now when I click again, everything went solid red and it's selected, but it's waiting for me to input F3 to tell it to select all these points. And so I go F3, and then it gives me a wizard. Do you want to pick your own lead in and lead out point? Just hit no at this point. And then it opens up a dialog box that's rapid plane. That's how far does how high above the table, or zero, the Z0, does the router move. I'm just going to leave that at 25. The material top, the core is 9 millimeters thick. Now cutting depth here, we want to go down to a depth of 7.9 millimeters, because the bottom, the type of inserts they have, the bottom flange on their inserts is 1.1 millimeters thick, so we want to route that deep. In fact, I'm going to go 1.2, so 9 minus 1.2 is 7.8, so we're going to route down to 7.8 here. We don't need roughing here, we're just going to do one cut because that's not a big deal. I'm going to turn down the speed quite a bit on this because this is doing a tiny circle, and if you have it go really fast, it doesn't cut the holes as accurately because the diameter is so small, the machine just doesn't have the resolution to do a tiny hole. So if we do it at 1,000, it comes in and it sort of does this hole, goes bzzz, real slow instead of going real fast if you got the router doing a real fast feed rate. So 1,000. And then I'm going to leave the plunge at F250, which is pretty slow but typical for what I do with most router bits, and hit next. Now the next thing we have to do, this is the tool offset, and we want the router to route on the inside of this line, so it leaves the 19 millimeter, like this is a 19 millimeter diameter circle. We want it to route on the inside of this line, so if you look here, it's going to the outside of the line because the tool offset is to the right. We've told the machine that the router bit diameter is 9.525, which is a 3/8 inch drill bit. The tool compensation is automatic, but we want to switch this to left, and you'll see how that moves the cutting to the inside, so the left or the right edge of the bit is going to route on the inside of the hole and countersink it correctly. So I'm going to hit OK. Boom. And it generated the code for just this first circle, and you can see how it drew the red is corresponding to this 3/8 diameter circle, and the edge of the router bit's actually going to go around this circle here. So that's done one of them. Now we just got to continue and do all the other binding holes exactly the same way. It won't take as long because I won't be talking all the way through it. Okay, so machine profile, select the geometry, make sure the arrow's going the right way, click again, hit F3, no. All these are all correct from the first time, so now that we've set it up the first time, we don't have to do it again, we just hit next, and this tool compensation is all set up from the last one, so we just hit OK, and it does the next one. So then that's done the second hole. Now we go machine profile, and we'll select this hole, make sure the arrow's going the right way, click again, F3, no, next, OK. Boom. Machine, profile, select, make sure the arrow's keying the right way. Oops. Click again, hit no, next, OK. So that's the next one, machine, profile, select it, make sure the arrow's the right way, click again, hit F3, no, next, OK. And so on, all the way through them all. Profile, 3, no, next, OK. Machine. It's kind of repetitive, and it's unfortunate it doesn't do them all at the same time, but that's the way the ball bounces. Okay. Machine profile. F3. No. Next. Okay. Machine profile. Select the geometry, make sure the arrow's the right way. F3. No. Next. Okay. Machine profile. Select the geometry, arrow's the right way. 3. No, I almost hit yes. That would have sucked. Okay. Machine profile. Select geometry. F3. No. Next. Okay. Machine profile. Select the geometry. Click. F3. No. Next. Okay. The reason the red lines aren't showing up here is because the dialog box is covering up here, and unless you have a CAD graphics card, the card doesn't refresh some of the geometry. It is working correctly. I could see how it was red after I do it, but you can see, unfortunately, the red line doesn't show here because I don't have a CAD graphics card in this computer. If you had a CAD graphics card, it would be refreshing and showing up. That's one of the reasons people spend money on good graphics cards when they have a CAD machine. This is just a cheap gaming card in this machine. Okay, machine profile, select the geometry, make sure the arrow's okay, hit F3, no, and next, and okay. Alright, so those ones are done. I'm going to move down to these bottom holes and keep going. Machine profile, F3, no, next, okay. Machine profile, select it, arrow's the right way. Oops, no, I don't want yes, so I'm going to stop here. Okay, do that one again. So machine profile, select this, click, F3, no, next, okay. Machine profile, select it, arrow's the right way, F3, no, next, okay. Machine, oops. Machine profile, select the geometry, F3, no, next, okay. Machine profile, select the geometry, F3, no, next, okay. Machine profile, select geometry, no, next, okay, and so on. F3, no, next, okay. Machine profile, F3, no, next, okay. Machine profile, select the geometry, arrow's the right way, F3, no, next, okay. Machine profile, select the geometry, arrow's the right way, no, next, okay. Machine profile, select geometry, click F3, no, next, okay. Machine profile, select the geometry, get the arrow the right way, hit the F3 key, yes, oops, no, I gotta hit no, okay. Machine profile, select the geometry, click F3, no, not yes, next, okay. So now, that's all the binding hole countersinking done in this file. If we hit the Z key, you can't really see the red unless I refresh it. No, you need a CAD card or you can't see all the red lines, unfortunately, they just don't refresh. But that's all our binding holes done. Now, the next step we want to do is make sure that our cursor is at the end of the program here. Then you want to click on this side for sure to make sure you aren't active, but the last spot we were active here is so that we're going to continue in the same file and cut the perimeter of this core. So what you do to that is you do the same profile command, but this time we're going to select a point on the geometry here, get the arrow going the right way, click, hit F3, but it's going to go around the whole perimeter of the board here. And again, we don't want to hit a lead in, lead out point. It's going to just drop in here and start cutting. So I'm going to hit no. We can leave rapid playing at 25, material top at 9, cutting depth. This time we want to go down to 0.2 because we want to cut all the way through the material but leave 0.2, a little paper thin bit on the bottom so we don't mark up the top of our router table again. This time though we want to enable tool roughing because you don't want to cut this in one pass. 9 millimeters, the router can definitely cut it in 9 millimeters, but if you push really quickly through 9 millimeters of material, you're more likely to cause it to split or cause little errors. So I usually like to cut in 2 passes. So it'll go around and cut about half the depth through it, and then it'll go down a little deeper and cut the rest of the way through it. So since this is 9 millimeters thick, if I select 4.5 as the depth of cut, it'll do 4.5 in the first one and then about 4.3 on the second one because it's only doing down to 0.2 because of the way we set this up. I'm going to turn up the feed rate to about 5,000 this time and leave the plunge at F250 and hit next. And that opens up our same dialog box, but now this time we want to have our tool compensation to the right because we want to cut to the outside of this shape. So I'm going to go to the right and straight plunge and OK. And that generates code all the way around the outside of our file. You can see how that did that. Now a way we can check this is, oh no, I'm not actually going to do that because there's too much geometry in this file. Sometimes I check this by doing reading this code back in here, but with all the binding holes it's just going to make a big mess. So at this point, if we do File, Select All, and then we can do a quick simulation of this in the simulation here. Now we're going to set up a dimension, a core blank. Let's say we're going to do a core blank of about 1800 millimeters long by 320 millimeters wide and 9 millimeters thick. 9. Okay. Oops, that's the wrong way. I'm going to close that. I'm going to go simulate, and I got to change this to 320. It considers the x-axis, the length, and the width 1800 this way. Okay, so you can see if I rotate this, there's where the router is going to start. So in this program, if you click Start, it's going to go drill the holes, drill the holes. This is going a little bit fast. And it's doing the countersinking right now. And now it's doing the board shape. You know, I'm going to run this simulation again, but I'm going to do it really slow. And it's doing it 2 passes, like I said. So I'm going to slow this simulation down quite a bit so you can see what happens. I'm going to close it and run this simulation again. All this geometry selected. Edit. Simulate. OK. And then I'm going to rotate it so that I can get a top view so you can sort of see what's happening. I'm going to slow it down again and start. And it's still going pretty fast, so let's pause it and go as slow as it'll go. Okay. Just doesn't want to go particularly slow. Countersinking. But it gives you an indication of what this file is going to do. It's not very accurate. You can see when I did it, I did a medium accuracy. You can do a little higher accuracy version. Well, here it's going slow on this. This process is. I can actually speed that up a little. And it's showing how it's routing. It's doing the second pass here. And so that's a kind of a down and dirty thing where you can see what it's doing. Now, these lines are just the toolpath of the thing. It's not actually routing into the material when it's doing that. Close that out. Okay, now one other thing I need to do at the beginning of this file, because this particular guy is using one of our CNC multi-cutters. The CNC multi-cutters, some machines just have a router that you physically turn on, but our CNC multi-cutters need some G-code to tell the machine to turn on the router because it's turned on internally by the electronics. So we're going to enter a command that's called the capital S 16,000, which is spindle rotation of 16,000 RPM, and hit the enter key. And you can see how that, and we did that in front of the very first command at the top, N000, so we're doing this. So the machine knows it's going to come on that speed, and then a command of M3 actually turns on the spindle. So it's going to turn on the spindle at 16,000 RPM and then cut this file. So now I'm going to save, I'm going to do one extra command in here as well, is a G64. What G64 does is you can see down here we've got all these fine little lines that are generated in SnowCAD or whatever CAD package this guy developed his file in. And then it goes to a smooth arc here, and then there's a bunch of small geometry here, and then a smooth arc, etc. What will happen is it'll move really slowly and jerkily sometimes when there's a lot of geometry like this. And if you add a G64 command to it, it tends to smooth the speed out a little bit. This file would run fine without it. It might just run a little jerkier. So I added this G64 command in here to smooth it out. And if the customer has any problems with it, he can take this command out if it seems to be cutting inconsistently. But I find as a general rule this G64 tends to help a lot. Anyways, file, save copy as. I'm going to call this file freestyle Kung Fu Panda core shape holes counters. There you can see my typing kind of sucks, and it's saved as a tap file. Tap is the extension of CAM files that read in, or G-code files that read into Mach 3. So save, and that's done. So that's kind of a long-winded explanation of how to go through, drill the holes, countersink the holes, and cut the shape of a core blank.